Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. So we're trying to build out the lute minigame, right? We have some of the mechanics, I'd say most of the mechanics, other than we need to like reset. We need to reset the notes, right? So like I did like last night I maybe worked like 30 minutes on it and I got it so that we are pulling the notes to be synced with the background notes. So we program this loop of a background notes to go, and then we play the melody on top of it, right? So now the notes are kind of in sync with the background notes. So if if we had a song where, because every note we put in the song, right, needs, the third parameter is time until the next note. So if we were to put, let's see, where is it? I think it's just in our lute system here. Yeah, so look, if we were to make our song instead to be just 4 notes, each with one I would say like a beat. So like how it's kind of set up, I was trying to get it so that we can change the rate at which the notes are scrolling. But there's a lot of factors into that, right? Because we're trying to loop the bass notes. So like these are the notes that we're looping, that we're supposed to play the melody over. And then if we were to put notes like this is like the first string, first fret, 1 second until the next note. And then we can enter a new note similarly, like second string, second fret, 1 second till the next note. We have to put, the way we do this is we're inserting them in curly braces because we basically do a loop within a loop to pull out any chords. So like if we wanted to play more than one note at the same time, we can do that. But that's why we have to put them in a little table notation here. So let's say third string, first fret, 1 second till the next note. And then one more, just so I can see and demonstrate that the looped notes are playing every 1 second here. So we could say fourth string, first fret, 1 second. So we should have 4 notes scrolling in. We messed up parentheses right here. So it should be like, let's see. So see these notes coming on. Now the notes, the bass notes should play as soon as these are on. So they're offset, right? So I have it more like 2. So the idea is if we want quarter notes, so a time of 2 seconds would be whole notes, because that's how our bass notes are playing. So a 2 second would be a whole note, 1 would be a half note, 0.5 would be a quarter note, 0.25 would be an eighth note, is the kind of idea. But ideally, I would like to be able to have this not based on delta time, but based on a BPM that we could pass. But I cannot figure out. There we go. So we can see the bass notes in sync with the notes that are coming onto screen here. So, but it's kind of like, we don't have it where we can adjust it very, very easily. I had this basically all I did was I went into the bass notes and I just played around until I got the right timing offset. So for whatever reason, it has to do with the speed at which the notes are scrolling, right? So this is saying timing offset of a 3.6 And then if we go look at our note is at a speed of 28. So if the notes are going 28 pixels every second on screen, then the timing offset is about 3.6 seconds to get them to start syncing. Ideally I have this where I can manually switch this and say, you know what, we want a BPM of 120 or only 60, and we can have the bass notes and the speed of the notes kind of scale towards the tempo, or have a locked speed for the notes scrolling on so that we can slow down the song and then the notes can still appear the same space apart from one another, because the distance in between a quarter note versus a half note versus a whole note, the only way to tweak that would be to change the speed of the notes, but that changes the timing for the bass notes, and then there's a lot going on. So I don't know how to do the scaling, so I'm gonna try to build out the melody we have in mind with the current bass notes and the current melody. So today's stream is gonna be building out the melody that we have in mind, but also we want to adapt the code. So like what's tricky, and I pulled this up yesterday, our music system, I drew it like this, which is like one way to kind of visualize it. Because on WASD, we're playing the different strings, right? So this is actually string 4 because it goes 1, 2, 3, 4, counting downwards. So this is string 4, this is string 3. Left is string 2, top is string 1. That's the WASD. And then we have 2 frets worth of note adjustments in between each one. And then I labeled which note they actually are. So it's just, it's tough because we're trying to play. We have this melody. I can play the melody for the most part on a keyboard, but when it comes to the game, it's tricky because I'm like, well, I don't know which note transcribes to which key and fret while I'm playing, right? So what I've been doing is saying, okay, well, I know it goes, for example, it goes A and then C and then E. So that would be string 4, fret 1, then string 3, fret open, and then string 3, fret 2. So when we go to input these as notes in our game here, we build them out like this: note, string, fret, and then we need to know the timing till the next note. So it's yeah, it's hard for me to build out the melody when it's like this. So I'm wanting to do something where we can say, like if this is just like some pseudocode, right? If we had a music table and we were able to say, just give me the music at the index of the B flat or whatever it is. And then if indexing that would actually lead into, ideally we'd have to give it a time as well. So we need to know the timing, but ideally it would be easier to say, give me a B flat, than it would be for me to try to do the mental gymnastics of like, it'll be 2nd fret 4th string to get the B flat or whatever. So like as I'm writing it, so I'm hoping that we can kind of play through. Yeah, I'm trying to think of like the best way to kind of do this. Because if we had, I think we start at a D3, so it'd be nice to say, but then again we have 2 octaves of B flats, right? So we have 2 octaves of B flats, we have 2 octaves of C, we have 2 octaves of D. So we can't quite just give it the note. We'd have to say, maybe we just trim it down to the number of note it is out of 12. So when I play the melody, I can just transcribe it on paper and just say it's 2 4 5 2 4 5, whatever. We have to find, the time after the notes is tough too, because we don't have any way to signify measures in our song declaration, so it's hard for us to know which beat is going to end up on a bass note, which is how I'm going to be kind of doing the timing. So it might be just a lot of trial and error, because we have to ship the demo. Well, we have to be done with the demo April 1st is our goal deadline. So I don't know how much rehauling I can do of the music system when it's this close to working. We have the valid note checker working like Guitar Hero, where if you press the wrong fret, or if you press the wrong string, let me word it this way. If you press the correct string but the wrong fret, it'll count as a wrong note. It'll count as a right note if you hit the right string with the right fret being held. And there's like a little bit of lenience. So like that's all working, and the notation is working, and the syncing is working. So we can probably go ahead and move forward with just making this one song, and then for the other 3 songs for the rest of the game, we might see the shortcomings of how we did it here and try to build it different. But we don't have time to redo it right now, and I don't know how I would redo it. So I think we got to work with what we got. So ideally we have to give some sort of method where instead of saying this nonsense, right, where we say note 4-3.5, like off the top of my head, I know that, well, that's not even a fret. We can't even hold frets up to the 3rd. There's only, since there's an A and B button for the Game Boy, it's just open string, which is just the directional, and then fret B would be fret 1, and then fret A would be fret 2. So yeah, ideally we would say something like this, where, I mean, maybe we can make, like if we had a function called like insert note or something, or like we just say, let's just say we call it insert note, and the thing would take 2 parameters. It would take a number, which would directly relate to the actual note we're trying to play, and then it would take in the time to next note. So if we had something like this, we could put, it still looks nasty. I mean, we would still have to put these curly braces and say note, but at least the note we're putting, see, I don't know, part of me thinks the numbers are just too confusing, because I don't know what a number 3 even means. In our game, it would mean fret 1. It would actually mean fret 4, or string 4, fret 2 would be this note 3 as a number parameter. Because under the hood, it would still have to go to this, where we're declaring a note, because a note is the object that it knows. It knows what to render on screen, knows how fast to scroll it, it knows how to render the valid note checker and everything. So under the hood, this insert note has to convert this number into our global sounds table, which maps to whatever number of note that it is. So 1 is actually a G2 in here. So like the 1 parameter would under the hood map to this, and then time to next note would be the parameter to be the time to next note, the 3rd argument in the note class. So yeah, it doesn't make a lot of sense. I mean, it's hard to, like, no matter how I slice it, I feel like. All I know is right now it's really hard to build out the melody when I'm just looking at this note, note, note. Because ideally, we can, I don't know, I'm trying to think of like a way we can even like break this up. I mean, we could have. I'm trying to think if we could put like little beats to help us track the measures. So like if this is 1, 1.5, 2.5, 4.5. See, nothing really maps up with what beat we're actually on. So it makes it hard to get the timing right when we're trying to program it, because we don't know which note of the bass note is going to be playing by the time we get here, unless we do all the counting in our head on the melody. Like we'd have to, yeah, it's like I'd have to like transcribe all the notes into the string and frets. See, and ideally, how do we do this? Like I just want to turn a number of string into its corresponding pair of numbers. So that should be easy enough. Like ideally, because as I play through the note on my keyboard, I can just look through my little cheat sheet and see which number out of 12 it is. And then we can make a table that the number of index we have would turn into a table of two values, and it would be the fret and the string, or the string and then the fret, right? So if we had this, and ideally this would actually look like this would be 4 0, because it's the fourth string, no frets. Index 2 would be fret 1. Index 3 would be fret 2. So if we had it like this, I can at least you know, I'm trying to think of how I would do this. Because if I had some sort of notation, right, where it's my own notation and I just say I have the numbers of what they are, I can kind of draw little lines at every whole beat, or any notes that sync up with the whole beat. I can kind of indicate on my drawing so that I can come back in here and say, okay, well, I know that this note would need a 1 because it's a quarter note, or a 2 because it's a whole note. That leaves us to sync on the third note right on beat with the bass note. So I don't know, man. This is a lot. This still doesn't really make it that much easier for us, because like we don't have a way, you know, like if we define a music table with all 12 notes as the string and fret, right? Then we can go into a note instantiation and just say, okay, well, the first parameter here is going to be C, and then it just gets nasty. It's going to say, oh, well, we're music 1, but the string is actually the first index, and then the second parameter needs to be the music 1 but second index. So now our thing is going to look like this, and then we say 2 for a whole note. So now playing the first note looks like this: note music 1 1, music 1 2 2, and that's just to play a G note, a whole note G note. Yeah, I don't know. I guess the move is I make like a table that literally just says all the notes I know we want to play by the numbers, right? So I can transcribe to the numbers just so I don't get mixed around, because it's weird for me to think that the 4th fret is the lowest string because it counts downwards. That's just how we did it, because it was kind of weird to count upwards. It's weird either way. So I say I just take my time and get the number of which notes we need to play. And then once I have a list of all the numbers, we can make a little cheat sheet for us that says, okay, every time we have a number 1, we need to replace it with a 4 and 0 for our notes, first 2 parameters here. And then kind of go through every note and just replace it with the right numbers. But yeah, it's just tough to get the timing right. I think it'll just be a lot of trial and error. I don't really know of a better way to try and do this. It's hard to express musical notation in code like this, you know? So, especially with whatever stuff we've got to work with, you know, we've got 12 notes on 4 strings, 2 different frets, and then they're scrolling on speed at a very specific rate, and we're doing that valid note checking. So yeah, I don't think building us a little table will help much, because it just looks gross, right? It just looks more confusing than just the note straight up. So I mean, I guess another thing we could do is, like, instead of a note, we can have a new function or class that returns, like, if we had this thing called I don't know, let's just say we have let's just do it music again, but this time music takes in a string. We could say it takes in a string parameter, and then it takes in a time to next note. So it would look like this. And then under the hood, a music, you know, well, it could be that this is called as a function, right? So this is a function. So I'm just trying to think if this makes any more sense. So if we had this and it takes in a number of string or a note number, so like note number, and then time to next, oh my god, what's happening? Time to next note. Okay, and then we return a note instantiation with the, you know, this is where we would go, we would take that note number, we'd take the note number, go into our 2D music array, and say, well, the music array at index note number is going to give us, you know, this is just pseudocode still, so this isn't really what it would be, but this would be like, let's say that whatever note number we give at this index would be equal to like a string for fret 0. Then could we insert, you know, we would say this, we would say local note gets this table of 2 values. Could we put in the note here and just pass straight in the time to next note right here? And this is what we return. It's a little weird because it's like returning the function doesn't call the function, right? So like this needs to be an object instantiated, not a value returned. So yeah, I don't know. I'm not really sure that turning it into a function helps us much either. So it just might have to be nasty, and we like, because I'm trying to think, you know, if we got 30 notes on this song, this thing's going to have 30 notes inside of it, and then if we need to adjust anything, every subsequent note gets affected by every previous note. So we'd kind of have to build it really slowly, make sure we're happy with it as we build it up, so we don't have trailing mistakes. You know, it's tough. It's tough. Yeah, it's quite a mess. I mean, I don't know of a better way to do it. And we're on a crunch, so we kind of just have to figure it out. You know, we'll just do it slow and try to do it right. So I guess the first step would be we have to lock down the melody so that we're happy with the melody, and then we can worry about the timing. Why my webcam lighting is all off. So I guess what I'm gonna do, we'll pull up Rolly Equator. I'll mute. Oh, we've already got it. What is going on? All right, this is just taking forever to load. Here we go. Okay. So I guess we just have to play around with the melody till we're happy with it and then lock it in, and then we just worry about the timing. So what I'm going to do is I'm going to get the bass notes looping here. And then I'll play from the selected notes we have. We've got from G up to D. So that's the range we have to work with. But then here I'll load up the notes so they're looping, and then I'll try to play the melody over it. So it's we've got to try to find it does kind of sound like Hitchin' a Ride that I'm thinking about it. Well, it's like when it's looping like this, it's so apparent how basic it is, but I'm trying to think, how does that song go? Is that the I'm having trouble trying to sleep? Is that the one? Gosh, man, it's tough. Okay. So, I need to take out some notes so that it doesn't, we can't have it too fast because it's just too hard to play on Game Boy. So we kind of have to slow it down a bit, but. Yo, Matt Birds, yeah, sure, do your thing. Rhythm-based approach to visualizing music. Yo, this okay. Yeah, it is definitely tricky. This is cool. Thank you. I will watch this and see. Yeah, this is cool. Yeah, exactly. There's there's so many different ways to go about it. Yeah. This is cool. Thanks for sharing, man. Yeah, I appreciate that. It is tough. And then what's tough is like, making it interactive too cuz it's like we need to not only visualize a made up tablature for this music, but we need to have the player be able to, gamify it and like playing correct notes, wrong notes. Yes. Okay, so Matt Birds, look, we've got we're working this out, but we've got where we've got we've got four we've got four strings and then two frets for each string. So we've got it has 12 notes. So they go, let's see. And then we're starting to build the sheet music here. And if you hit the wrong note, it's wrong, right? But oh god, it's so tough. It's so tough. So we're it it's like we've got pieces of it together here. It's just like trying to actually transcribe the music and have it sync with the bass notes and stuff has been really tough. So it's like it's one thing to play it on the keyboard, it's another thing to try to play it in my own game with the weird fret and string logic. So I'm trying to lock down the melody as simply as I can and then transcribe it into my game notation here. I did notice that our neutral open strings didn't seem to be detecting correctly. So this should be first fret, second string. Okay, so there, I think only the open notes weren't triggering correctly on the valid note checker. This is so crazy though. Valid note checker. What did we call that? It was a valid note checker class. We take the note's position and see if it matches the correct. What are we doing here? Okay, so we cycle through all the active notes. So any notes that are on screen and scrolling, then we check that active note. And we check, what is this? Active note 1 would be the very first active note. So like the next one on screen. And then we're checking the note within that, so the actual note instantiation, and then the X position of the actual note class instantiation, and see if it's smaller than this 12 pixel range. And then we're checking that instantiation string number and the fret number, and the string has to be the string that we're checking the valid note checker on, but the fret has to be equal to the resulting fret output of whatever A and B buttons are pressed. Then if at that point in time, if it matches and it's not been wrong already, if you get it wrong, you can't get it right. But if it's not wrong yet, then go ahead and set it right. Otherwise, let's just set that active notes invalid timing to true. Invalid timing or valid. And we needed both of those, even though it's a Boolean. We needed both to render it correctly, I think. Okay. Yeah, I mean, I don't know where the open notes are going wrong. Let's test if the open notes are just not working. So let's say that we want string 4, no fret, 2 notes, so like a whole note. And let's just have 2 of those. We want both open strings to test. Okay. Yeah, I think so too, Matt Bird. I think the notes playing in the background help the rhythm a bit. Like you get 2 visual cues, right? You get the notes scrolling on to the, I call it the beat zone, like wherever the notes end up where you need to strum. So you get that visual note, but then also the musical bass notes coming in. So this should be the first string. So look, we got it wrong there. So yeah, it looks like the open frets are just not working. If we had, say, fret 1 on both of these notes in here, those valid note checkers seem to be working. So fret 1, and we'll hit string 1. Yeah. So if we hit it too soon, it's red. but if we hit it right on time, it was good. So we're just not checking the, because we're not checking. Okay, so frets held. Yeah, frets held is a table that basically gets updated. You know, if you, I think we're even rendering it. Let's see, frets held in the render. I think we're doing this. Holy crap, 69 references. Okay, frets held. So yeah, if I hold fret 1, it is just fret 1. If I hold multiple frets, frets held gets overwritten by whatever precedence of fret. So it's like fret 2 will overwrite fret 1. So fret 1 is either, frets held is either an empty table, meaning we need to check valid note checker for an open line string, and then frets held, we're already correctly checking the valid note checker for frets held being hit. So let's go back to our valid note checker. This is in our lute. See how we're only checking the valid timing. That's what's controlling the green rendering or not. And that's also we're also gonna be triggering. You know, I think we'll give the player like 3 chances or three missed notes in order to correctly play the song, just because it's tough. It's tough. Like, it's tough for even me. So we want to give some lenience for that. You know, ideally we have that where we can slow it down, but any slower, the song doesn't sound as good. And it would be cool, you know, if you get like once the song is kind of made, then there's going to be like a little on the select button, you can reload the song and practice it again. So if you mess up one part, you just reset it and try it again. So we need to also check, you know, we're only checking if the fret being held is okay. Thanks, Soup. Yeah, I'll check it out. I'll definitely check it out. Thanks, dude. Yeah, I think we need to, because right here we're only checking if we hold a fret. Well, we're checking if the fret is equal to the value that's in frets held 1, but frets held index 1 isn't always a value. It's empty if we're doing an open note string. So we kind of need, you know, because this else if is catching. Otherwise, if the next note on the page is string is equal to the string that we're checking valid note checker on. So when we strum, we check if it's a valid note to know whether or not to color it. So basically, if you strum a string and it doesn't equal the string of the note that's next, it'll mark as wrong. So I guess with this method, we're actually only counting wrong notes as the same string but wrong fret, as opposed to if you strum, like, let's say a note's coming on string 1, if you strum string 2, 3, or 4, it doesn't count as a wrong note. So it is lenient in that mode too. So if you accidentally hit the wrong note, the wrong string, then you can be like, oh, I actually, that's one string below, and then you can hit the right one and still nail the valid timing for that note. So it is a little lenient in that way too. But we need to check valid timing for an active note with a fret that is equal to nothing. So our frets held table would have to be empty, and we can check if it's empty, I think, by just asking if it's nil. So maybe, you know, first thing we do is we check the positioning of this. Yeah, we'd have to kind of do something similar where we say, well, else if we're in that active spawn. We have the same string, but the fret, we'd have to ask, because fret would be 0 right here. Fret would be 0. So if fret is equal to not 0, but an empty table of the fret held, we'd have to say, well, I guess, yeah, because we need to know if the player's actually holding any frets at this moment. So we do have to ask if frets held is nil. So for right now, let's try to do this where we add an else if, and we say else if frets held, and let's just test this, if frets held is equal to nil, meaning there's nothing in there. I mean, I never understood this with Lua, like if because it seemed like, nil is kind of like an uninitialized table, right? But I feel like, I don't think we can say if frets held is equal to empty table. I don't think that works. I think we have to say nil like this. But let's just say this, if the frets held, if there's nothing held in the fret, but we're playing the string, then let's set that next note's valid timing to true if the frets held is nil. So the no frets held, let's see if any 0 fret note is going to pop up. Feels so weird without the music going on stream. Okay, so we're wanting to go to our song 1, and we want to make sure all of these require no frets being held. Okay. Nope. Nope. Okay, so frets held nil. If this frets held equals 1, okay. I guess, well, we can say this. We can say if the value of frets held index 1, Soup's favorite, does not equal nil, or actually does equal nil. Yeah, if there's no value in the first index, then we're going to set the valid timing of the open note string. So let's test a wrong one first. Oh, it tested right. It tested right. Okay, so it did render a valid timing, but it was way too soon. So yeah, see how it's green way before it should be correct. So it's because we aren't checking the X position. So we do have to ask if this active note, the next active note in our table, and the note instantiation in that table, X position is smaller than 12 on the screen. That would be, we have a 12 pixel buffer for those notes to be played correctly. So now let's try to do it. I'll try to hit it right before I think it's valid. So it should be red. Yeah. But then if I hit it closer to valid, it turns green. Okay, so I think we got that. So that should be, this is the open string check. And then this is missed note. Okay. Okay. So we've got that. So I think we just need to settle in on the melody. Man, the webcam exposure's all jacked up. Okay. So yeah, I think I just need to get, man, it's tough. It's tough to get the I want the melody, like it's funner when I do like little flourishes and stuff, but on the Game Boy game it has to be simple. So we have to simplify the melody so that it's not too many inputs. But also, I want it to sound good when you get it right. So like have a little balance cuz we'll give the player like 3 strikes or so of missed notes before they fail the challenge. So I think the move is for the rest of the stream to add some helper functions like reset the notes. Right now we don't have a way to reset the notes, so I just quit the game. So if we can have, if you're in lute state, to hit select, and it won't pull up the minimap, but it'll pull up the, it'll actually just reset the notes that are scrolling on screen, reinitialize them, and start scrolling them again. And then also, if we had like a correct note timer or a correct note count and a missed note count, those will all be helpful for the final feature. So if we can get those things working, then I can off stream get the melody where I'm happy with it, and kind of get the notation pulled out so that we can instantiate our song up here. It is gross, it's just a whole table of notes, but I don't know another way to do it. So yeah, we would need to reinstantiate. So like, what do we need to do to reset a song, right? We would have to, it's tough because at least for the stuff that's looping, man, this is getting tough. Because yeah, if we would, let's look at our bass notes and see what is in there. So it just has a table of notes, a timing offset, a timer, and an update. So basically anything in our init here needs to get reset on our bass notes if we press select. So let's find where we're doing our lute state logic, and I'm gonna get my music back. That's better. Okay, yeah, we need to do where we're updating our notes and stuff in our lute state, which isn't a real state, which I don't really like, but we're doing this where we say if our lute is equipped. Why do we do this? Item slot 1. Item slot 1 is our B slot. So if action B, yeah, we only have our lute available in our B slot right now. So we're saying if we're in, yeah, if we have our lute equipped and we press the B button, then we're gonna change our animation. We're gonna become in lute state. Okay, so here we have, well, if we hit select, we come out of lute state. So instead of doing that, let's see, because I think what I want to do, I think select, I want to be the reset, and I want start to be exit lute. So let's see what start is in lute mode. If we hit start, we pull up our inventory. So it really shouldn't pull up our inventory. It should pull up it should actually do this. So like if start is pressed, we're gonna come out of lute state. Now I'm curious if, yeah, if we're in lute state and start is pressed, then we're gonna come out of lute state, but I'm curious if we'd pull up the inventory. So we're gonna be in lute state, we're gonna hit start, we do pull up inventory, and we're out of lute state. So let's go to where we're turning into our inventory system, because that's a little wrong. We call it pause state, which is not what I like about it. So start does manually take you out of play state. We only want start to change you, actually. Uh-oh. Yeah, let's see this where we, anytime we change to start, you know, it would be in this pause state, whatever it is. Pause right here. Pause. No, title state. Pause state right here. Okay, so if basically in our pause state, pressing start takes us back to play state. That one's right. But here in our play state, if we press start and we're not dead, go ahead and change to pause. But we have to say also if not lute state. You know, I do think I want to pull lute state into its own actual state machine. So we don't have to do these nested things. But we did not do that from the get-go, and we're trying to get the demo done. So this'll be okay for now. Let's see. So we should have where start doesn't take us, it just takes us out of lute state. Now start takes us to inventory at that point, but our lute doesn't get reset. So if we do this, anytime we hit B again for lute, it just resumes, but it should reset everything. So it should reset our bass notes, it should reset our song, and it should reset our lute state. So we need this, like, when do we say lute state gets true? Right here. So this is right here. We need to go to our lute object, which we have. It's right there. We need to basically run the reset on there. We don't have a reset, but we'll add it. So any lute trigger, when we trigger lute, we're basically going to say trigger lute state. Basically what we want to do is say here, we want to go to our lute object, which, is it called lute? Just lute capitalized? Yeah. Okay. So we're gonna say we're gonna take our lute object. We're just gonna reset it. We don't have this function just yet, but we also want to set our bass notes. What is our bass notes object called? It would be in our lute. Bass notes is bass notes 1 and song 1. Okay, so it's almost like we would also need to clear this active notes table that exists in our lute state. But I guess if when we reset our lute, it resets the active notes, that'll be taken care of for us. So we should be able to just also do a reset on bass notes, which in our case is bass notes 1. But also, was this a global function? Yeah, it's global. So bass notes has an update and a timing offset and everything. So we should just take that bass notes object and also do a reset of it here. And we need to do this not only on a triggering of lute state. So if you exit and come back to it, it would reset these things, but also if you hit select and you're in lute state. So, you know, I guess we should have another if lute state, but if lute state, then if our input, if select is pressed, then we want to also reset the lute and reset our bass notes if we're in lute state and we press select. So let's define these functions in these classes so that we can reinitialize them and make sure they're working, and then we can add correct notes hit and missed notes hit, and then also resetting those values too upon a reset. So once we have that set, you know, we've already tested the valid note checker for open strings and frets 1 and 2. So then the game is kind of working. Then we just have to make the song with the right notes. So that would be huge if we just get this stuff working. Let's start with our lute. So we'll go into our lute. You know, we need a couple of things like this. We need a function called reset. So it's a function on the lute itself, and it is reset. Takes no arguments. It will flush the active notes table. See, how does this work? Like, active notes is local to the lute. So I'm curious, if we call this method due to closure, we should have access to this, right? Because it's defined in scope of, because this function should know what this active notes is. I don't know if I call it outside, if that actually works. So that might be something to try. But we need a couple of things. We need to flush our active notes, and then we need to I guess that's mostly it, because what happens is in our lute update, we got to get rid of all the old touch detection because we modified it now. So I think we might need to reset this song timer. Song timer is what triggers the notes to come on screen. So how it works is, like, there's a whole table of, say, 20 notes. We only pull the very next note one at a time to spawn, and we only spawn it every next note time. And then we delete the notes from the active notes table. So it's like we take, like, the original song, make an active notes table, pull it one note at a time, pull it in there, update its position, check for valid note checker, and then we remove the notes one at a time from the song and reassign the next note time. Okay, so I think we need our song timer to be 0 as well on the reset. So we're gonna say song timer is also at 0. Let's see what else is hiding in the update. We have a next note time that we probably need to be whatever, defaults to whatever this is. So next note time is just 0. Okay, anything else? Active notes will be flushed. The song itself isn't ever removed. We don't take any values out of there. We might, we flush that anyway, so that should be okay. So let's see if when we hit select, it'll flush our active notes, or if we've got to do something different. Because I'm just worried that this active notes, you know what? This is a little weird. No, this kind of makes sense. Yeah. So this active notes is this local table of active notes. I'm just worried that when we call this method, if it knows that this is local, I don't know. So once we do a lute reset, this should be in our play state, I think. Yeah, lute reset. Okay, so let's add our bass notes reset, then we'll test it. So we need to find our bass notes. Okay, so it looks like all we should need to reset is all this stuff. So let's add a method to our bass notes, and takes no arguments, and it just resets the notes. The notes remain unchanged, but current note is 4. We reset the current notes. Okay, that should be it. We just reset the timing offset and the current note and the timer. So that should reset everything. So let's test it. Let's see if pressing select will flush our current notes and reset them. So I'm going to hit select, which is H in our case, and it still pulls up our minimap. But when we come back, yeah, it doesn't look like it's resetting our notes here. So let's make sure that our select press is not pulling up our minimap if we're in lute state. Select change to minimap. So we need to do this only if and not lute state. Yeah, I want to do this more in an actual state machine for that, but we just have not done that yet. Okay. So I'm going to hit select here, and it definitely cleared the notes, but nothing's coming on screen now. So we're missing something like the bass notes wouldn't be it, right? It would be the lute. So if this is all that it is, what we could do is when we go to do our lute reset, we could, because I think there might be something with variable closure in there that it can't read. So we might have to do this and say, instead of a lute reset here, upon a select press, instead of the lute reset, we're going to kind of just actually like directly touch those members. That sounds so bad. Yeah, and just clear them there. And then if this makes new notes come on screen, then it was something with closure probably, but I don't know. Okay, we're gonna hit select. Oh, I didn't see anything happen there. If input is select, we're gonna well, you know what? It did. Can we not go into no, yeah, we should be able to go into a lute instantiation like that. We're just missing some values, I think. I mean, let's just look through. You know, if we flush this active notes, we know this is working because the notes on screen disappear when we hit select. So we know this is working. We know these values are probably right. So we must be missing something in, you know, song timer is 0, next note time. Those are all the values we messed with. And then we say for as long as, oh, we are removing from our song. Okay, yeah, we are moving from our song. So we can't be deleting from our song here. Yeah, so by the time, yeah, we can't do this. We have to do this differently. We could just duplicate our song into song 1, and when we refresh it, we have to assign song 1 to be equal to the original song. Yeah, I don't know. It's kind of messy. Let's go to our lute. Let's go to our song 1. Because we're flushing it here, but then we're assigning it right here. Okay, so like, let's say we keep everything as is except we have a global song that is going to be set equal to this song 1 right here. Should be the same exact thing that's in our song 1. So when we reset, we need to make sure that we take our song 1, which is our now depleted song, and we assign it to be our original song. That might fix it. Let's just make sure our lute reset is there. Select note reset, lute reset, yeah. Okay, let's see. We're looking for more notes to scroll on after they disappear, proving that we kind of reset the song scrolling on. So let's see, we're going to hit select here once all notes are on screen. It deleted them, and we don't get new notes. Oh my god. Yeah, not working. Song 1 gets song. I don't know. I mean, we table.remove from the song if the song timer and next note time is passed. So we are resetting that. We should be able to. Yeah, it's almost like. I mean, what we're doing should work. We're just reassigning song 1 to be the original song. I don't know why it's not working. We could try printing up song 1. So new note time, song timer. Oh, next note time. Next note time. Next note time. Okay, I just read it wrong. Next note time. Song timer, active notes, song 1. Okay, I mean, what's not happening here? Like, is this assignment just weird? Let's try this where we say, let's say original song is this table. Then we're going to say, let's copy into song 1, the original song, and see if we have any notes on screen. Because this, I would think that this would be straightforward. Oh, it doesn't like it. Can't get length of song 1. Song 1. Do we have to assign it in a table like this? No. Why can't we do this? Because I don't want to have to just duplicate it, but yeah, I don't want to have to duplicate it. Something I'm not understanding about Lua tables. I mean, oh crap. Okay, we might have to looks like Chat God is saying, since it's a reference, right? Passed by reference, not passed by value. It's not copying over this So we'd have to copy one by one the values, which is kind of making sense because all the table is an address. So if you're passing the address and we're deleting songs from the same address, copying the empty one doesn't help us any. Hey, what's up, Pocket? Yeah. So we've got to, if we want to copy this, okay, so we're going to loop through. We're going to loop through our song. And we're going to say that the index, we copy over each index. Now, this shouldn't be it. This should be cycle through our song, value, yeah, the first, so V is gonna be every note instantiation, and V1 is every actual note object, I think. So this should give us with a original song equaling what we define song 1 as. So in our lute reset, we're going to set song 1 equal to what our original song was. And test that. Am I working on changing music by play state? Yeah, I'm working on just resetting the music. So like our lute state is part of our play state, which I don't particularly like, but it's just right now it's an easy way to just render the correct scene behind us. We do need to stop updating. Yeah, it isn't its own state. So right now, if we pull out the lute in this room, the bat will come and kill us while we're playing lute. So it's just over the play state, which isn't quite right. Yeah, isn't quite right. But who am I to say you can't play lute when you're getting murdered by bats, you know? This still isn't working. I'm gonna be a dummy real quick and just try this. Let's just say our song 1 gets reset as the original song. When we press lute reset on a select, we just want to see notes coming back on screen when we hit select here. Still not working. I don't know what's different. Yeah, I'm not too worried about it right now, Pocket. We'll add it. I'm more worried about actually getting the lute working, and then we'll do the polish like that at some point. towards the end of the month. But yeah, it should be fairly easy. Like there is a paused toggle we can do that pauses everything from updating except the animatable sprites in the map. So if you're next to water, the water would still be flowing, but enemies wouldn't come crawling at you and stuff. So I think that's probably what we'll do. Something isn't right in the lute reset. We're just not getting the notes. We could print up the value of our song and see that it's not getting reset properly. Or we could... we basically just need to create the lute song for people to play, Pocket. We have where they can play the wrong notes or right notes, but we need to actually build out the song melody. So I've got the melody like in mind, and I've got the bass notes working, but we don't have little helper tools. It's the second one, lute. I know, I think it's funny because it's most games have a lute system, but this game has a lute system. There's a big difference. We could, like, I'm at the point where I'm just trying to see if it's because we just need to reinitialize our song 1 correctly, or if something bigger isn't getting reset here. So if we hit select, we should see these notes come back on screen. Okay, they do. So we just weren't doing our proper reset here. So I'm gonna have to figure out how to do a deep copy of this stuff, because this isn't working. Because we basically take the song and we take one note at a time out of the front of it until there's no more notes left. So that's kind of how we're playing the song note by note, starting from the front. So I don't like this where we're taking it out here. I want like a deep copy reset so we don't have to just initialize it. But we've got to go. I think what I'm going to do next is, now that we've got at least the reset working, I'm going to make sure that the bass notes work. So Pocket, we've got we've got this system where we've got strings and frets. So we have strings and frets, and then we have these bass notes that play over and over and over. So you're supposed to play the melody over the bass notes. But, I need to make sure the bass notes reset. I hit the wrong button. Oh, it does. At least this reset's good, so that's good. Okay. Nice. Yeah, so the reset works for the bass note timing too. And yeah, the bass notes are to help the rhythm, but also the rhythm is part like when the note hits the active note zone on the left, whatever. I call it like the beat zone. Whenever the note hits there, that's when you're supposed to strum. So if you, like, the circle is an open string, so if you do it too early, see, it's red because I missed it. But if I wait and hit it on beat, it's green. So we've got that in there. We just need other little things, like we need to count how many notes you get right, count how many notes you get wrong, and then basically do like we need to get the reset working so that it's a little prettier. But this is most of the way there. Then I just need to actually put in the correct notes at the correct time. So it's getting there. I'm going to take a quick break and I'll be right back. And yeah, pocket, I think this will be super easy. Let's do this. Correct count. Incorrect count. And then basically we have this valid note checker. This is what was turning them either red or green. So anytime we turn green, we're going to increase the correct count. So we're going to say, yeah, super easy. Correct count gets incremented. We do that for both correct notes, and then if it's incorrect, we decrement. Okay, so we increment the correct values upon if you hit it or miss it. And then let's just go print them up real easy. This won't be, I don't know if we'll have the correct count showing to the player. This is mainly for debug and testing purposes. I think we might give like 3 X's or something on the bottom of the screen if they hit. Yeah, if they hit when they miss notes, like maybe it'll say, yeah, just 3 red X's or something. But I'm not too worried about that right now. More worried about getting the melody in the game and having it actually playable. So we're going to print up the correct count, and we're just going to print it. Let's just say 20, and we'll go virtual height minus 40, I don't know. And we also need to flush it upon a reset. So we should also go to the reset and just say both correct count and incorrect count get 0. And then we're going to print up correct. Let's see where it prints. Correct 0. Yeah, we need to make it a little higher and to the left. Okay, so we should have the correct and incorrect count on screen here. Too high, too high. Okay, here we go. So I missed it, so incorrect went up. Yeah, okay. So it's not accounting for, if you go and get the right note and hit it over and over and over again, it counts more correct than you got. Like, it should limit correct count to 1 per note, and same with incorrect count. Because if we go and hit this correct multiple times, see, we got 9 correct, even though there's only 2 notes. So, yeah. I guess, yeah, we need to only increment it if it's not already correct. Because the valid note checker... Let's see, so... I don't know how we would do this easily. because we need to not increment this if it's the same note that's already been incremented. So this is just when, you know, we check if it's a valid note. We could just, you know, whenever we go to check if this is a valid note, we do this in a bunch of different aspects, and we say, well, anytime the string is pressed, we're checking if it's a valid note. So we don't have a way of saying we already checked this particular note. Yeah, we would have to add it to the note itself. Yeah, we'd have to add it to the note itself because the notes are what stream across the screen. So we'd have to add it to when we go correct count. Yeah, we'd have to check the note. You know, it would be something like this. We'd say if the active notes at index 1, which is the next active note, but we go into that actual object and say checked already. You know, if it's not checked, then let's go ahead and give it that. And we become checked at this point in time. And we could move the same thing for the valid timing, but the result is the same. It's just, yeah, we wouldn't be reassigning a true boolean over a true boolean, but that doesn't really matter. If it's not checked, then let's go ahead, make it checked, and increment the count. So we should need to do, just initialize this to be false. And we'll do this for the same thing over here, you know. If we only increment the correct count if that particular note is not already checked, and we only increment the incorrect count if that note has not already been checked. So in our note class, we should just be able to crap. Yeah, we should have just a self-checked initialized to false here. Okay, so now let's see if we get index complete. I'm not sure what you mean. Let's try to get more than 2 correct. Okay, 1 correct, 1 incorrect. So it looks like it works. Yo, Pocket, I'm ending stream here soon, so I might be gone when you're back, but yeah, I think I'm gonna end stream here. I think I'm gonna take a nap, and then I'll probably work on the melody and the deep copy of the original song so we can clean up that a little bit, and then we might have our first song playable by tomorrow sometime, depending how many notes I get made for tomorrow. So we'll see. I'll see how far I can get tonight inserting the real music, but for now, thanks for watching. I'll be back tomorrow, hopefully with some new music, like a full song in there, and we'll raid out here. You know, we'll raid out to who? I don't know who to raid to. Looks like Finn is doing. Here, we'll raid out to JD. He just started, so we'll No, he didn't. He's been up an hour. Whatever. We'll just raid JD, call it a night. Thanks for watching, everybody. I'll be back tomorrow.